Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In the past 3 videos, we started talking about decision trees. But one thing among all of those videos were common. We used decision tree for the purpose of classification. But in the first video, we actually saw decision tree can also address or solve prediction problems. So our agenda in this video is to sort of see how decision trees can be modified. I mean, at least the one that we saw can be modified so it can address also the prediction task. All right, let's look at this slide. All right, of course, like any other videos, we're going to have a few recaps, very short, the stuff that we need to remember from the previous videos, and then we're going to talk about this issue of how do we sort of like separate the decision tree for classification and the prediction as far as their namings. There are different names that are used, potato, but we're just going to look at them and see what are they. And then after that, we're going to look at the three, differences, technical differences between decision tree for classification and for prediction. And then using examples, we are going to put those differences into context. So by the end of this video, you will have a pretty good understanding of how decision trees for regression are done and how is it compared to decision tree for classification. So, we did talk about how decision tree can be can both handle classification and prediction. This is something we had seen. So if you remember, the similarity between prediction and classification is that we want to connect the dependent attribute with some independent attribute, right? So this is what we are trying to do. And of course, for classification, this is a categorical attribute, or target is a categorical attribute. For prediction, this is classification. For prediction, our target is numerical. Right, so this is the difference between prediction and classification in general. For classification, we had a sort of like categorical, in this case binary attribute, and we used what we did. If you remember, we had an induction algorithm. We would use an attribute test to figure out what split to use, and we filtered the data again and again, so we get to pure leaf nodes, meaning that all of our class labels were the same. So that's what we did for classification using decision tree. So before we talk about technical aspects of the decision tree, how it's going to be different for the purpose of prediction, let's talk about how do we call them, right? So decision trees are, also can be called decision tree classifier or classification decision tree. These are the names that we use. Regression trees, decision trees, regression trees, this is, one of the ways you can address them, decision trees, regression trees. But also you can call them decision tree regressor, decision tree predictors. You can call them prediction decision tree and regression decision tree. All of them are referring to the same thing, which is using decision tree for prediction task. All of these. So, we can call them regression trees, decision tree regressor, decision tree predictor, regression decision tree, or prediction decision tree. It doesn't matter, just a matter of names. All right, so there are 3 differences as far as the technical aspect of using decision tree for prediction. Of course, the first one is the difference between prediction and classification. The target or dependent attribute is numerical. So our data set for the target of our problem should be numerical. So this is something we already knew. What are the other 2s? The first thing is the concept of purity. If you remember, it was a really big part of induction algorithm. We would choose the attribute to split the data that would lead to the most purity of our subsets of our data, right? So that's what we use for classification. So that has to change because purity doesn't make sense for a target that is numerical attribute. And of course, the labeling that we use for classification, we would look at the subset that comes to a leaf node, and then if all of those attributes were pure, and we'll say, okay, this is that class, right? So for numerical attribute, we're not going to have a class of, this class or that class. So not only the concept of purity is not going to make sense, but also how are we going to label the leaf nodes are also going to be something that we're going to be doing differently. So we're basically going over these three things. So in this example, that we use for classification, imagine instead of having this target, so these are our independent attributes. Imagine instead of having the paid loan full, which is if the customer paid the loan in full, we wanted to predict the credit score of the these customers. So pay attention that the data changes. Now our target is numerical, right? This is basically the same data, but now we want to be able to predict their credit score, right? So that's the first thing that is different. The data has to be different because prediction needs a target attribute that is numerical. Then the second thing is the concept of purity. Actually we would capture impurity, has to be changed so we can use it with numerical attributes. Purity is a concept for categorical attribute. If we want to use decision tree, a similar concept for regression, we have to use the concept of variation. And there are a few metrics, such as there were a few metrics for the impurity. There are a few metrics that we can use for variation. And these are the ones: squared error, MSE, Friedman MSE, absolute error, mean absolute error, and Poisson. So these are the few metrics that we can capture variation. And of course, if you think about this, a variation across a data set is sort of the same thing, fundamentally, as impurity across across a categorical attribute. We don't call it that way. I don't want to confuse you, but this is basically the same thing. If the variation is too much, it means they're way two different things. If the variation is smaller, it means that these things are more similar, right? So that's what we're going to use instead of the impurity. We're going to use variation, and one of these can be used for that, right? So how did we use purity or impurity, right? Do you remember when we were doing attribute tests? We would check if we were to split the data by the education level, what would be our impurity? Do you remember? It was 0.25. If we were to do with years in current job, what would be our impurity level? It would be 0.4 or something, and this would be 0.4 something, right? So this is what we did when our task was classification. So here we would do the same thing. We say if we were to split our data using education level, let's say, for example, what would be our MSE, right? So what would be our MSE? So we calculate that, and we would find the split that leads to the least MSE for each of these attributes. And then we would compare these best MSEs from each of these attributes, and then we would split the data based on that attribute and the split that leads to the least amount of MSE, right? So this MSE could be different. Any of these, we could use them: squared error, mean squared error, Friedman mean squared error, absolute error, mean absolute error, and Poisson. So we could use any of these. It's sort of what do you call it? It's the hyperparameter, one of the hyperparameters we could tune for our problem. But anyway, we just basically what we do, because our target is not categorical, we change the impurity metric with a variation metric. That's all we do, right? So it's not a really huge difference as far as the second one between the classification and prediction of decision tree. So what is the third one? The third one, if you remember, when we were labeling the classification, we would either label it with the most frequent class in each leaf node, or we would say, okay, how many of each class is there, or we would say what's the percentage of these frequency. So we would use one of these. For regression tree, we only can use one of them and one thing, and that's the average of the data objects that are in the leaf node. That's all we have to do, right? So let's remember how we did it for decision tree. If you remember here in this node that we decided it's a leaf node, we could say, okay, because we've got 4 yes and 1 no, let's just call this a yes. Or we would say, let's just be explicit. We have 4 yes and 1 no, right? Or we could say, let's just put the percentages. Like we would say 80% yes and then 20% no. So these are the different ways we did this for classification. But how about regression trees when we have credit score here? All you need to do when you reach a leaf node that you want to put the values, put a label for the leaf node is to calculate the average of these values, right? So this is the average of these values, and you're done, right? So if you pay attention, the changes that we did to the structure of the decision tree algorithms were not earth-shattering. They were like very surface level changes that changed the algorithm to be used for classification to prediction. All right, so let me just wrap things up with a very small summary. We did talk about how we call these two versions of decision trees. There are many different names. Not many, there are a few different names you can call them, but it doesn't really matter. I mean, I think it's very easy. When there is a regression, prediction name into it, it's a regression tree. When it's not, or it's decision, or classification is decision tree, or classification or decision tree. And we did talk about those 3 differences that needs to be made to the algorithms and the data, so a decision tree can be applied for the purpose of prediction. Until the next video.